Okay, good morning everyone, good afternoon. Today I will present a recent research paper which is about active control model combining frequency domain information for noise and vessel segmentation. This work a process of novel segmentation method called ASFDI, which combine Fourier transform based frequency and information about active contour model to accurately segment the blood vessel in noise medical image. Okay, what was the problem? The problem addressed this paper about medical vessel image segmentation and their noisy condition. Image often contain a noise caused by image sensor equipment vibration and acquisition process. This noise makes it difficult to identify blood vessel boundary accurately. Traditional active contour models are sensitive to initial contour selection noise parameter setting. Deep learning model can achieve a good performance, but they require a large annotated dataset and significant computational resource. Therefore, the author aimed to develop a segmentation method that works more effectively for noise image. This is the reason of using Fourier transform, does not require large training dataset, is less sensitive also to initial contour selection, maintain a very high segmentation accuracy. The application domain is the medical image specification return blood vessel segmentation. Okay, what are really the related work? Traditional models include traditional deep learning approaches that were used for Fourier transform are DRLSE, RSF, RESL, RLSF, and IELSM and ALVLS. These methods rely on edge information or region information, but often suffer from a really very sensitive from the noise. However, the deep learning include in UNet and UNet 3. Other these networks perform well, they require extensive training and have limitation interpretability. The key difference of ADVS is that in introducing frequency domain information obtained from Fourier transform directly to segmentation process. This allows the model to automatically generate initial contour and guided contour evaluation more effectively. Overall methodology, the overall pipeline, let's check the pipeline. Here's the pipeline. The overall pipeline contains four main stages. First, the vessel image is transformed from the spatial domain to frequency domain here using a Fourier transform. The second is a low frequency and high frequency region extracted. Third, low frequency information is used to create the initial contour automatically. Fourth, high frequency information is incorporated into energy function of active contour model. Final level of evaluations to perform obtain a vessel segmentation. This workflow eliminates a manual contour initialization and improves robustness against noise. Fourier transform frequency domain. The key mathematical is a Fourier transform. Convert the image from spatial to frequency domain. Main image process even by low or high frequency. For low frequency, as we already talked in the sessions, is for smoothing and the region and major structure. The high frequency is mainly for indicating the edges. Shows the smoothing for low and high frequencies. These are images compares the low and high. This is, for example, the noise, which we call salt and pepper noise. These are the indicating of edge. This is a very noisy, which need to be removed by low pass filter. The LFRM, which is a low pass frequency, is used initial contour. Traditional active contour model require manual selected initial contour used as highly sensitive to their placement. The proposed method avoid this issue because low frequency also region already contain a very global vessel structure information, which we need to avoid. So going to the high frequency domain. Now for the mathematical For the math, let's start with the mathematical computation. Total energy is presented here, where A indication for the area, L is the length term, and R is the regularization term here, which we take it from Hench law, and we all know that the regularization term is the lambda. The other modified both area and length using frequency informations. These are also G is presented for kernel, incorporate local. Here's the kernel. Incorporate local neighbor information, improve robustness against noise. And these where we take differentiation. Okay, what about the experiment setup? Were conducted on dataset contain of 100 return vessel. So we start the experiment from here. We have like a 100 dataset contain vessel image, and the image size were 128 by 128 pixels. The type of noise were added to the Gaussian noise, poisonous noise, salt and pepper noise, as you can see here. We compared against all of these methods. If you check this one, to investigate and compare the effectiveness of different model is segmentation noise. We compare over all of these models here. And the training validation or split and deep learning model consists of previous experiment. These are the evaluation indicator for all of these models. Here we can check the accuracy, Jaccard and Dyke for all of these models, which been conducted. These are the Gaussian points, and as mentioned earlier, salt and pepper noise, and how they are, and here we're checking the mean for all of them. These are the models. Here we're going to involve a filter where output comparative model using above 3 energy function are conducted in 100 image as specified earlier. The average and for Dyke values, it was in the table showing, which was really higher. If you check here the table, if you notice, it was like a 0.2, which is higher than Jack, and accuracy in Gaussian method. These are the Fourier filtering generator. Parameter adjustment remain inseparable, as you can see. Okay. Now, the main strength in this paper is about automatic contour initialization, strong noise robustness, no training data required, good interpretability compared with deep learning method, high segmentation accuracy. However, there are also limitations. First, the method is specially designed for vessel-like structure. Second, the parameter tuning is still required. These are very important information need to be. To conclude, this paper presented for ADCI novel active contour model that combine frequency domain information obtained through Fourier transform with the level set segmentation. The low frequency information provide automatic contour initialization, while high frequency information have a really guide contour evaluation. The experiment result demonstrate a very robust and accurate, especially for noise vessel image. Overall, the research provide effective and interpretability alternative purely deep learning based segmentation method. Thank you all for this presentation.